Hi, my name's Andy Elliott from HVA Factory, and I want to talk to you a little bit tonight about clutch adjustment. And this video assumes that you've watched the previous video about clutches. Okay, so this is in effect part 2. So I have an engine here tonight, but this could be any engine from 1976 all the way up to 1986, which is the last of the 5-spring clutches. This happens to be a 4-stroke. These happen to have a deeper clutch hub, but the principles are all the same. So this engine's just come out of a bike, it's clearly been well used, and the clutch adjustment is too tight. The stack of plates has worn, and that's pushed the push rod back, reducing the amount of free play in the clutch arm. So I'm going to adjust that. There's something to note first. Any bike before 1985 has a clutch push rod which has a 4mm ball on the end, okay, like this. So that's the 4mm ball, and this is what you find for the actuator shaft. Okay, so the ball operates against the actuator shaft. What always happens with these is that the ball wears until it's flat, and you end up with almost a hole in the actuator arm. The answer to all of the bikes is to replace these parts. The later actuator arm has a cam profile, and the later push rod is flat on the end, and this gives you slightly more lift than the old arrangement, and it does mean that wear is not so much of an issue. So this is a later bike, it will have these parts anyway. The other thing you can also do is, when the actuator arm is in position, on top of it in the casing is an oil seal. You can replace the oil seal with a bearing, okay? Obviously we stock these. And on top of the bearing, between the bearing and the clutch arm, we use a motorcycle tube valve rubber cap to seal the top of the bearing. Although it's a sealed bearing anyway, this just stops you from jet washing anything into the bearing, and when the clutch arm goes on, that all squashes together nicely to seal the job. Okay, so this engine will have these pieces anyway, and all you do is 4mm Allen key, 3mm Allen key, 10mm spanner. So you rotate the thrust bearing until you feel the hole line up, which locks the pressure plate against the clutch. Okay, so with that locked, you can then release the 10mm hex, and what we're looking to do is to adjust some free play into here. And before I do that, and now that I've undone it to relieve any pressure, you can see that this whole assembly is moving backwards and forwards by over 1mm. So, as I explained in the previous video, you can tune out that play by replacing the two 1mm thick washers that are inside the clutch, either side of the clutch, with slightly thicker versions to reduce that play until it's just under 0.5mm is ideal. And the reason for that is that if I adjust this back up, you can see everything's moving in and out as I pull the lever in. So in effect, until you reach that outward point, the rest of your that's not free play. Okay, that's just moving the whole clutch assembly, which is why we like to tune out this end float. So for the purpose of this video, like I say, go back to the previous video and I talk further about tuning that out. But we'll assume that that is down to less than 0.5 millimeter. You do need some free play because when everything gets hot it still needs to be free, so don't shim absolutely all of the play out. You do need a little bit of something there. Okay, but what I'm looking to achieve with this in its out position is somewhere about 10 millimeters of free play, plus or minus a millimeter. Okay, so I've adjusted that to about 10 millimeters of free play, and the reason for that is as the clutch wears, this arm will go back and you will lose the free play, which is why you need to adjust the cable on the lever. But it's important that that is genuine free play and that you're not just moving the clutch backwards and forwards, so deal with the shims. Okay, so with that in its position of 10 mm free play, it's just a case of lock the clutch, and there you are, good to go.